Imagine humans living in space for 1 million years. That's a long time. It's almost impossible to picture. But we can think about it. What would happen to our bodies? How would we change? It's not science fiction, it's just biology doing its thing. Evolution doesn't stop. It just adapts to new surroundings, and space is a very new surrounding. First, let's talk about gravity. We've always lived with gravity. It pulls us down, it makes our bones strong, it makes our muscles work hard. In space, there's not much gravity, or maybe there's none at all. This is a huge deal for the body. Bones would change a lot. They would get weaker, they wouldn't need to support much weight. So, they would lose density, they would become lighter, our skeletons might look more delicate. They could be almost brittle if we came back to Earth, but in space, it wouldn't matter as much. Bone marrow could change too. It makes blood cells. The body might become very efficient at this. Or maybe it would produce fewer cells, it just wouldn't need as many red blood cells to carry oxygen. Less oxygen demand means less work for the blood. Muscles would also shrink. They wouldn't need to fight gravity. Our legs especially would get much smaller. Walking wouldn't be a thing. Movement would involve pushing off surfaces or using handholds. So arm muscles might stay relatively strong or even get stronger. But leg muscles would become weak. They would be thin, maybe even vestigial. People might have very long, thin limbs. Their bodies would adapt to movement in zero G. It would be an elegant slow motion glide. The spine would lengthen. Gravity compresses our spine. Without it, the discs would expand. People might grow taller. A few inches, maybe more. This could make them look more slender. Their posture would be different. It wouldn't be a terrestrial posture. They would float. They would not stand upright. Their heads might sit differently on their necks. There wouldn't be a need to hold their heads up against gravity. Our hearts would change too. The heart works hard to pump blood against gravity. In space, it doesn't need to work as hard, so the heart would get smaller. It would be less muscular. Blood pressure would be lower. The total blood volume in the body would decrease. There wouldn't be a need for so much blood. This could make humans very sensitive to gravity. A return to Earth would be dangerous. It could be fatal. And what about the head? Blood tends to pool in the upper body in zero G. This makes people look puffy-faced. Over 1 million years, the body would adapt. It might find new ways to circulate fluids. Maybe the face would look different, less prone to swelling, or maybe the skull itself would adapt. The way blood flows would be different. These are just the effects of no gravity. But space is also a vacuum, and it's full of radiation. Our skin would have to deal with this. Radiation is dangerous. It can cause mutations, it can cause cancer. Humans in space would be exposed to more radiation. Even inside a spaceship, there's always some. Skin would change. Melanin protects against UV radiation. But space radiation is more complex. It's cosmic rays, it's solar flares. Our skin might become thicker. It might develop different pigments. It might not be about getting a tan. It might be about blocking specific particles. Maybe our skin would be very pale. There's no sun to make us tan. Or maybe it would be darker. Of a different kind of dark. A protective dark. It's hard to say. The skin could also become more resistant to damage. It would be tougher. Hair might change too. We have hair for warmth and some protection. In space, heat regulation is different. Spaceships are climate controlled. Hair could become thinner. Or it could disappear entirely, or it could become a different kind of hair, maybe fine, dense fur for radiation shielding. That's a possibility. It's not just about aesthetics, it's about survival. Our eyes would be different. In space, the light conditions are strange. Inside a ship, it's artificial light. Outside, it's blinding sun or total darkness. Our pupils might adapt to wider ranges of light. They might be very large, they might be very small. Our eyes might see more of the spectrum. Maybe infrared or ultraviolet. That could be useful for navigation or for seeing details in dim light. There might be less need for color vision, or more. It's about what becomes useful. Also, the inner ear. It helps with balance. It tells us which way is up. In zero G, up doesn't exist. The vestibular system would change. It would atrophy, or it would adapt to different cues. It would use visual input more. It would use touch more. Our sense of orientation would be very different. We wouldn't feel dizzy in zero G, but we would struggle on a planet with gravity. Food in space is different. It's synthetic. It's processed. It's recycled. Our teeth might change. We might not need strong teeth for chewing tough food. Our jaws might become smaller. Our teeth might be weaker. Or maybe we would evolve to use specialized tools. Our digestive systems might adapt too. They would become super efficient. They would extract every nutrient. There would be no waste. Or very little. Resource scarcity is a big deal in space. Our sense of smell and taste would adapt too. If air is recycled, it's filtered, there might be fewer complex scents. Our sense of smell could become duller, or it could become hypersensitive to specific compounds, maybe for detecting leaks. Or for finding food sources. The same goes for taste. Food would be engineered, it would be designed for nutrition. Taste might become less important, or it might evolve to detect tiny variations in manufactured meals. Hands and feet are also interesting. Our hands are for grasping, for manipulating. In 0G, this is even more critical. Our fingers might become longer, more dexterous, more sensitive. Our thumbs might become even more opposable. We might develop extra digits, or our existing digits might become superfine manipulators. We wouldn't need powerful gripping strength. We'd need precision. Feet, on the other hand, would change greatly. They are for walking. For standing. In 0G, they're just anchors. They push off surfaces. So our feet might become more like hands. They might develop opposable toes, they might become more flexible, they could be used for gripping handholds. Or for precise pushes, they might look like another pair of hands, or they might just shrink. They might become small, almost useless appendages. Think about the overall body shape. Less gravity means less need for a strong frame. The body might become very slender. Very elongated, almost like an alien. It wouldn't be dense, it would be light. The head might be larger in proportion to the body. That's if the brain continues to grow, or if the brain adapts to new information streams. Or it could shrink if intelligence is linked to efficiency, not just size. The immune system would face new challenges. Spaceships are closed environments, they have their own microbiomes, exposure to new pathogens might be limited. But any pathogen that does get in could spread fast. Our immune systems might become specialized. They might be good at fighting internal threats, they might be less good at fighting external ones. This could make contact with Earth dangerous. It could make contact with alien life very dangerous. And what about reproduction? Conception in 0G is a mystery. Fetal development is a mystery. Childbirth is a mystery. The female pelvis might change. It might become narrower or wider. It might adapt to easier births, and 0G babies born in space might have different bone structures. They might be more flexible. They might have a different growth trajectory. The whole process would be alien to us. Parenting would be different too. Children would learn to navigate 0G from birth. It would be natural for them. The brain itself would evolve. How we think, how we perceive. Our senses would be different. So our interpretation of the world would be different. Our navigation in 3 dimensions would be second nature. Depth perception in vast, empty spaces would be crucial. Our understanding of time could also shift. Long voyages, artificial day-night cycles. This all affects our minds. Social structures would also influence evolution. Humans in space would live in small, confined communities. These groups would be tightly knit, or they could be prone to conflict. Social selection would play a role. And traits that promote cooperation would be favored. Traits that promote harmony. Aggression might be weeded out, or it might be redirected. This affects brain development, it affects behavior. Radiation resistance is a big one. It's hard to evolve radiation resistance quickly, but over 1 million years, it's possible. Our cells might become better at repairing DNA damage. They might have more efficient antioxidant systems. Our bodies might produce new compounds. These compounds could shield our cells. We might be able to withstand doses that would kill us today. Our metabolism would also become hyper-efficient. Resources are always limited in space. Every calorie counts. Every drop of water. Our bodies would waste nothing. They would extract maximum energy from minimal input. Our base metabolic rate might drop. We would need less food. We would need less water. We would be living machines of efficiency. Sleep patterns could change. We have a day-night cycle. But in space, it's artificial. Our circadian rhythms would adapt, or they would disappear. People might sleep in short bursts, or they might go into longer periods of torpor. The concept of a 24-hour day might become meaningless. Consider communication. If vocal cords are used, the acoustics in a spaceship are different. Sound travels differently in air. And in structures, our voices might adapt, they might become softer. Or they might be very resonant. We might also rely more on visual cues, or on direct neural interfaces. Old language itself could change. It could adapt to these new forms of communication. The skull might adapt to brain changes or to eye changes. If eyes become larger, the orbits would expand. If the brain grows, the skull would grow. If the jaw shrinks, the face would change. The overall facial structure could be very different. It might be less robust. It might be more refined. Bones and muscles that support internal organs would also change. Gravity holds our organs in place. Without it, they can shift. The body might develop new support structures, or organs might simply float. They might settle in new positions. This would affect internal anatomy. It would make us very different inside, too. The entire skeletal system would be lighter, bones are heavy, they're a significant part of our body mass. Less mass means less energy needed for movement. It means less stress on structures. A million years is plenty of time for this to happen. The bone matrix itself might change. It might be less calcium dense. It might use different materials. Our blood might change color. If less oxygen is needed, red blood cells might carry less hemoglobin, or a different kind of oxygen carrier. This could subtly change the hue of our skin. It could change the color of our blood. It's a small detail, but it shows how deep these changes could go. And what about psychological changes? Living in confined spaces, for generations, with a finite number of people. This affects our minds. Our tolerance for solitude could increase. Our need for social interaction might decrease. Or it could increase for a very small, specific group. Mental resilience would be key. Those who adapt to the solitude thrive. Those who don't struggle. This is a form of natural selection, too. The human connection to nature would vanish. No green grass, no blue sky, no fresh air. This would change our psyche, our aesthetics, our desires, our fears. We would evolve beyond needing these things. Or we would create artificial versions. This would shape our minds, it would shape our dreams. And then there's genetic engineering. We're talking about natural evolution here. But a million years is a long time. It's almost certain that humans would use technology. They would guide their own evolution, they would make deliberate changes, they would engineer resistance to radiation. They would engineer stronger bones, they would engineer better eyes. This would speed up evolution. It would make it more directed, so the future human might not be just naturally evolved. It might be a combination, a mix of natural selection and self-directed change. It's hard to separate the two over such a long span. Humans would likely have chosen to optimize themselves. For the space environment, they might have better night vision. Living in dimly lit spaceships, or near distant stars, they might have highly specialized hearing for subtle ship sounds. For danger alerts, their skin might be almost translucent, or bioluminescent. Imagine seeing your own circulatory system. Or glowing softly in the dark. It's not so far-fetched. Their bodies would be perfectly suited to low-gravity life. They would be efficient, graceful, almost weightless in their movements. Their muscles would be fine-tuned. Not for power, but for precision, for control. They would drift and flow, not walk or run. Their immune systems could be very different. They might not get sick in the same ways we do. They might be immune to Earth diseases, but vulnerable to others. They might not even recognize Earth bacteria. It would be a foreign environment to them. Their diet would be synthetic, so their sense of taste might be very different. Perhaps they'd crave specific nutrient profiles, not complex flavors, or maybe they would have entirely new taste receptors. For things we can't even perceive, their internal organs might be differently arranged. Without gravity to pull them down, they could be more dispersed or more compacted. The body's internal architecture would be re-engineered by evolution. It would find optimal arrangements for zero-G and their reproduction. It might be a fully managed process. Gestation might take place in artificial wombs. Or the mother's body would have adapted perfectly to deliver a baby in a gravity-free environment. The baby itself would be born without ever experiencing gravity. Its bones and muscles would form in its absence. Their perception of time would be vast. A million years is an almost unimaginable span. Generations would come and go. Entire societies would rise and fall, all within the confines of a spaceship. Or a fleet of ships. Their history would be different. Their sense of identity would be different. They would be space humans, not Earth humans. They might have evolved a way to hibernate, to save resources during long voyages, periods of low metabolic activity. This would be a huge advantage. It would change their physiology profoundly. Their need for food and water would drop to almost nothing. Their bodies would enter a deep sleep, and their brain would change. It would process information differently. It would interpret the universe differently. It would be a mind shaped by the void, by the stars, by the isolation, by the vastness of space. It would be a mind unlike ours. They would be a new species. That's what a million years does. They would be distinct. They would look at us and see primitive ancestors. Their bodies would be finely tuned and optimized for their existence. They wouldn't be weak. They would be strong in their own way, or adapted to their home, Their home is space, and they would carry the legacy of a million years of that adaptation. They would be the ultimate spacefarers.